When given two coordinates to solve for slope, you have a couple options. Even on your EOC, most time in class, and hopefully you can print some if you don't have some at home, you should have graph paper, as much graph paper as you want on EOC day, if you're a visual person versus an algebraic person. So when given 2 points, even though it would say just find the slope of these points, you can go to your graph and still graph them like we did in our previous videos. So 0, 2 means, remember, again, this is X, this is Y, so right, left, then up, down. So 0, 2, and then 4, 3. So 1, 2, 3, 4, 1, 2, 3. You can connect these lines if you want to. Remember, if you're looking at it, this is going up to the right, so we know it's a positive line. So we know our slope is going to be positive. And then you're going to count your rise, 1, and then 1, 2, 3, 4, run. So again, if you think about pedals, because sometimes people get a little confused in the way they draw their own over there, that line you can't see very well, but it's rise 1, run 4. And remember, it's rise over run, so rise over 4. So the slope for that first line is 1 over 4. You also can do it, so we're going to do the next one. So 0, 3. So again, don't go left, right, just go down 3. And then 2, 1. 1, 2, 1. You can connect your line. Again, it's going up to the right, so it's a positive line again, so we know our slope is going to be positive. And then we're going to count our rise. So 1, 2, 3, 4, over run 1, 2. So that's going to be a 4 over 2, positive, because it's increasing to the right. All your Y values are increasing as your X values are increasing. But remember, we're now in high school, so we never want to leave a fraction unreduced. So 4 divided by 2, hopefully we know is 2. So the rise over run is actually 2 over 1, 2 over 1. So again, graphing it, you may be able to see that depending on how straight you draw your line. You can use the edge of a piece of paper. If you have a ruler, that's even better. Or you can use the side of your calculator, side of a book or a notebook to make your lines a little straighter. As I've said before, the more neat you make yourself be, the less apt you are to make a careless error. And you're just down to fighting yourself on those other mathematical calculation errors. Okay, so 0, -1. 1, 1, 2, 3, 4. Sorry, these guys overlap quite a bit. So we're going to draw up. I'm going to use a different color than that red just since they do overlap. So 1, 2, 3, 4, 5 over 1. So rise 5, run 1. So rise 5, run 1. And again, as we've discussed before in our previous videos, 5 over 1 is going to always look like a whole number 5. And this really would have been 2 over 1, which we made into that whole number 2, because all whole numbers have that imaginary 1 underneath, which doesn't usually matter, except that if it does ask for rise and run, remember it rises 5, runs 1, and it is a positive line again because it is increasing to the right. So 0, 3, 0, 1, 2, 3, 4, 1, 1, 2, 3, 4, 1. Connect your line if you want to. As you are watching from left to right, this is going to be going down. So we know this is going to be a negative line. So from left to right, it's going down. So that's a negative line. We're going to count our rise and our run. So rise 2, we go to the left, 1, 2, 3, 4. So rise 2, left 4, which we also know is negative. And you can put the negative on the 2 or the 4. It doesn't really matter because the whole fraction is negative. So wherever you put it is fine. 2 over 4 can be reduced. That's a -1/2. So a -1 rise and a positive 2. So again, that would be 1, 1, 2, and that one would happen there if your line is drawn perfectly straight. If it's not a huge deal, because again, as long as you remember to always reduce your fractions, it'll come out in the wash, as I like to say. 0, 1, 1, -3, 1, 1, 2, 3. You want to connect your dots. See, like that line wasn't very straight. But we count our rise and our run. So we rise 1, 2, 3, 4 to the left 1. So again, you see this is going down when it comes to the right. So it's going to be a negative line. So rise 4 to the left 1. So -4 over 1, which again we write as just a -4, unless it's asking for what is the run, what is the rise. And then you want to remember that it is always a fraction no matter what. We also have the option for your algebraic solvers. You guys were probably taught y2 minus y1 prior to this class, x2 minus x1. And that is perfectly correct. That is awesome. If you're good at it, keep at it. I have a cheat that I use because I'm not super great Like I speak to you as I would do my own self, as far as like making sure I stay really neat, making sure I stay really focused in that question. And sometimes I get my Y's and my X's mixed up, or I pull a Y2 and an X1 instead of Y2, X2. So just keeping everything in order and perfectly focused. So mine is called Stack 'em, Subtract 'em. My little cheat hack, I guess you could say. So I'm going to use some of the points from above that we already know the answer to. So we use 0, 2, 4, 3, which was our first one. And so when I speak of Y2 and Y1, the idea is that this is Y2, this is Y1, this is X2. When we're saying 2, it's like the second coordinate, and X1. So then at that rate, when you plug it in your equation, if we put our Y2, Y is always on top, which is, oops, sorry, I meant to write 3. So 3, disregard. And then our Y1 is 2. Our X2 is 4. And our X1 is 0. Now, most of you aren't going to use 2 colors, but the idea is that you're keeping them, the yellow guys together in this case, and the purple guys on top of each other as well. So 3 minus 2 is 1. 4 minus 0 is 4. And that's that 1/4 slope like we got when we graphed it and counted it in the first graph. Now, for stack them and subtract them, if I take my first coordinate, so 0, 2, and then 4, 3, and you can space them out if you want, I know that I'm going to subtract and subtract. So 0 minus 4 is a -4. 2 minus 3 is a -1. We know that y always has to go on top, and y is the second number, so -1 over -4, which reduces, or simplifies, I should say, to a positive 1/4 again. So the stack them and subtract them helps me just keep the correct order between the 2 coordinates and not to mix up x's with y's. So let's do the next one. Let's do 0, -3, 2, 1. So again, we have x1, y1, x2, y2, and then we're going to put our y2 first, so 1, and our x2 first is the way the formula is written. We have a -3 and then a 0. Y's are always on top, so rise over run. We're going to subtract and subtract. And notice that you have a double minus, so subtract a negative, which makes that a plus, which means I'm going to have 4. 2 minus 0 is 2. And when we reduce that, it's 2 with a rise of 2 and run of 1. Again, just like the second one we did above when we graphed. Now, if we stack them and subtract them, so 0, -3. And if you stack 0, -3 on the bottom, it doesn't matter. It comes out in the wash. 0, 2, 1. The benefit to spreading them a little bit is to make sure you remember to put the minus in both. The only thing I've seen students do is just put the minus in the front and then you work straight down and add. So make sure you know that this is subtraction and this is subtraction, just like your formula over here has. It's just a different organization. So then I have 0 minus 2, which is a -2. -3 minus 1 is a -4. Y is our second column. We know it always goes on top. So -4 and -2 gives me a positive 4 over 2, which we know is 2 as well, just like the previous. Now to make up, I'll challenge you to pause your video right after you try this one, or right after I get this one written down, and see if you can come up with a slope. Do either way. You can use your formula, or you can use the new stack 'em, subtract 'em, y on top. Stack 'em, subtract 'em, y on top. You probably want to add that, y on top. Stack 'em, subtract 'em, y is always on top. All right, pause it. Try it. So we have x1, y1, x2, y2. We're going to put y2, so that's a -5. x2 is a 1. And then we're going to put y1, which is 2, and x1, which is 3. Y's are always on top. Then we're going to subtract straight across. So -5 minus 2 is a -7, and 1 minus 3 is a -2. The only thing we can do to reduce this guy is get rid of your double, or simplify, because it's not really reducible because 7 is a prime number, is get rid of those double negatives, because double negative means that is going to be a positive. So it's going to be a 7 over 2. And then to our stack, subtract, in case that's what you did. 1, -5. Remember, we're going to subtract. 2 different, like 3rd grade level, I think, is when you probably started doing the 1 column subtraction, if not somewhere around there, either way. So 3 minus 1 is going to be 2. 2 minus minus, remember, that's going to be that a plus. So 2 plus 5 gives me 7. Y always goes on top, which is our second number. 7/2 is our slope. All right, guys, hopefully one of those works for you when you're given two coordinates. It's much like the table as well when we counted around the outside. If you stack them this way, how did I get from 2 to -5? We went -7. How did I get from 3 to 1? We went -2. And by that I mean like when we were counting like this in our tables in our previous videos. But whatever works, whatever sticks in your head. Like I said, my favorite is stack them, subtract them, Y on top. But the idea is you just have to know the differences in Y's and the differences in X and know Y goes on top. All right, guys, have a great day.